Okay, today we are going to talk about self-efficacy. This is the final final meeting in our training series on building positive math attitudes. And this session, if you look at the materials I sent you, it's a little lighter than what we have in the other sessions. We don't have any specific teacher's guides for specific activities. And that's because the research on self-efficacy really points to more broad classroom-based practices in general that promote self-efficacy, which don't lend themselves to nice, neat, tidy teacher's guides. So in your materials for the self-efficacy session, you have, per usual, a PowerPoint slide deck and then a facilitator guide to walk you through that deck. I should say I'm joined today by Lauren Bates. Lauren, you want to say hi?
Hello.
And we will start off by, as we have in past sessions, talking about the research behind self-efficacy before launching into those classroom practices. And this is a session where I would start with an icebreaker to get people thinking about their own self-efficacy. And one way to do that is a question like this that asks, think of a time when your performance surprised you, a time when you succeeded or even failed unexpectedly. And how did that success or failure impact your feelings about yourself and your abilities? And this is a nice question to get people really grounded in thinking about what self-efficacy is, because it is so tied to our actual performance and our past experiences around performance. We're going to skip that question today, but this would be a nice one to break the ice and get people thinking about self-efficacy. Our goals today are not only to define self-efficacy and understand the roots of how it's formed, but also understand the importance of self-efficacy for outcomes for students, including engagement, but also performance. And particularly, of course, as we have in our previous sessions, we're tying this directly to students' experience in the math classroom. So we'll end with some actionable strategies for building math students in math, their self-efficacy. This slide looks familiar to you, hopefully. And this is Camille Farrington and her colleagues' model of the kinds of things that promote more positive academic outcomes. And if you remember from our previous sessions and her very large lit review of what promotes academic outcomes in the non-cognitive sphere, she has a model where she suggests that the research really points to academic mindsets promoting academic outcomes by way of leading to the kinds of academic behaviors we know are important for success. And she has distilled that research, she and her colleagues have distilled that research into 4 key academic mindsets. Today we're going to be talking about the second of those, which is I can succeed at this. And this is self-efficacy. Self-efficacy is this belief tied to a specific task. And it's what a person believes about their chances of success at a specific task. If we want to get really jargony, we can use Bandura's original definition, and it's the belief that one is capable to organize and execute the course of action required to produce given attainment. Really rolls off the tongue, but we can nicely boil that down into the belief about success at a given task. Research on self-efficacy comes from Dr. Bandura's research on and social cognitive theory, which was work pioneered by Bandura to try and understand how people learn and the social aspects of that. In today's session, we will talk specifically about student self-efficacy in the context of math. It's really important when we think about what self-efficacy is to remember that this is our perceptions of our performance capabilities specifically. And that's in contrast to the kinds of beliefs we have about ourselves more generally and about kind of more global personal beliefs about our personal qualities. So when we talk about math self-efficacy, we're not talking about statements like, I am a math person, but instead we're really drilling down to be more specific. And it's, I believe, for instance, I'll be able to solve this set of fraction problems. It's really about performance and really about belief and being able to execute and perform. Another thing to keep in mind about self-efficacy is it's very personal. So we're talking about our judgment of our own capabilities as opposed to how well we stack up against our peers. We like this quote from Henry Ford, whether you think you can or think you can't, you're right. And we like this because it really nicely sums up in a tidy little package why, as educators, we should care about self-efficacy. What we believe about ourselves and how we expect to perform are really powerful influences on how we actually perform. And this is because how we expect to perform affects a range of other variables like motivation and effort and how we respond to challenges in the moment. Self-efficacy is tied to specific domains or abilities. So this means a student might have different levels of self-efficacy beliefs depending on the subject. For instance, you might feel very efficacious when it comes to English and writing and your abilities, your musical abilities, but have less of a sense of self-efficacy in other domains. You can drill down even further than that and think about how students may feel efficacious in some aspects within a domain, but not others. For instance, in the math classroom, it's entirely possible that a student could feel positive and efficacious about certain types of math problems and not others. Thinking about self-efficacy brings to mind other forms of self-beliefs, and I think it's important to take a moment and compare how those different variables compare to one another. So here we have a table we've adapted from some resources from Transforming Education, and I really like this for helping set the stage for how self-efficacy is distinct from concepts of self-esteem and growth mindset. So self-esteem, this is students' more general and global sense of self-worth. Questions about who am I, what is my worth? An example of a statement you might expect from someone who has a high sense of self-esteem is, I am a confident person and a good learner. So that kind of example shows and paints the picture of really more broad beliefs about the self and the self-concept. In contrast, self-efficacy, as we've been talking about, refers to a person's belief that they can actually carry out what's necessary to achieve a specific task or goal. So this is asking the question, can I do this specific task? Can I do this specific set of problems? And the answer, for instance, would be yes, I am confident I can solve these factoring problems, drilling down to the specific as opposed to the global. And of course, growth mindset, which we've talked about in previous sessions, this refers to a person's abilities, a person's beliefs about whether their abilities can change over time as a result of effort, perseverance, and practice. So this gets at beliefs about ability to grow. Can I do this? Well, I can't do it yet, but I know I can get better if I study hard, try new strategies, and seek help. High self-esteem and a positive growth mindset are often, or we would expect them to support self-efficacy, but they're different concepts. It's easy to see and expect how these things might be interrelated, though. For instance, students with high self-esteem that have generally positive opinions of themselves are likely to start out in novel situations with a strong sense of self-efficacy. There is massive literature on the relationship between self-efficacy and academic outcomes, which we've summarized here with hitting some of the key points about the kinds of things self-efficacy is related to. And I think this paints a really compelling picture that teachers really should care about their students' self-efficacy, because we see that students with high self-efficacy are more interested in their academic pursuits, they persist longer, they're more engaged, they also respond more productively and adaptively when they encounter challenges or setbacks, and of course they show stronger academic performance. We also know that students are more likely to seek out situations in which they are confident about their abilities, and they're more likely to avoid those in which they are not confident. So we've boiled down the research here, but I think what we're seeing is a story of where self-efficacy is really an important driver of motivation, which in turn impacts achievement. Why would we expect students to try and put forth effort if they don't believe they're going to be successful? For a student who thinks trying is useless, that they have no chance of succeeding, it makes sense that they would disengage and be unmotivated. Bandura's research and theorizing on self-efficacy has shown that self-efficacy beliefs are formed by several overlapping factors that influence an individual's self-efficacy beliefs in a given area. And some of these are more potent and more influential on efficacy than others. Specifically, the 4 sources of self-efficacy are first, mastery experiences. This refers to students' past experience, whether or not they've had positive or negative experiences with this particular activity in the past or very similar experiences, and these are going to be the most influential source of self-efficacy. the student had success last week on algebra, they are going to expect to be successful again in the current week. The other three sources are less potent and less influential, but have also been shown in the research to be connected to self-efficacy beliefs. These include vicarious experiences, when students have seen others who are similar to themselves experience success or failure with an activity. It's important to keep in mind here that students are likely to discount a model that is deemed irrelevant. So for instance, it's much more powerful to watch a peer succeed than it is to watch a teacher model something successfully. The other two components that influence self-efficacy are social persuasion, people telling me I can or can't do an activity, and finally, physical and emotional states, whether or not students have experienced a positive or negative physical and emotional sensation when they have engaged in an activity. This probably reminds you of our talk about math anxiety and how that physical sensation of nervousness and anxiety is really connected to students' confidence. So this is a quote from Bandura that nicely sums up what we've been talking about, that people's level of motivation, their affective states, and their actions are based more on what they believe often than what is objectively the case. And so in a training, we would display this quote along with some key questions to start a discussion. And those questions get at whether or not teachers agree that beliefs are a powerful determinant of academic behavior, and also whether they have seen certain groups of students who seem to enter the classroom with more or less positive beliefs about their competence and ability. And the purpose of this discussion is to set up the next part of the slides when we return to this concept about how some students are likely to step into the math classroom with less positive attitudes than others. And in our trainings, we've often talked about how gender can impact math attitudes. You've seen this quote before about how boys don't pursue math at a higher rate because they are better, but rather it's because at least partially they are better. They think they're better, excuse me. This slide should also look familiar, where we have talked about how students' beliefs about themselves as learners and stereotypes that affect those beliefs are likely to play a role in inequities we see in math and other science, technology, and engineering fields. I'm not going to go through the specifics of this slide since you've seen it 3 times in the past now, but this is a key point we want to hit in all of these trainings that helps people understand why some students are more likely than others to come into the classroom with a less positive attitude about math. Now, at this point, we want to transition and get to the good stuff and talk about classroom strategies to build self-efficacy. And so I'm going to turn over the reins to Lauren, who's going to walk us through this portion of the training.
Hello, everyone. I'm Lauren Bates. If you if you missed the introduction that Karen gave, thank you so much for joining us. And as Karen mentioned, that there's a little repetition between what you've seen before and what we're presenting today, just because these concepts overlap quite a bit. But we're fully expecting you to take ownership of these slide decks and materials and tweak them as you see fit for the teachers you're working with. And so please feel free to take these modules and cut and swap and do whatever makes sense for you to be successful working with the teachers you support. So when it comes to classroom strategies, we're going to I'll make sure that the strategies we're talking about today are aligned to those 4 key aspects of self-efficacy that Karen touched on earlier that are based on Bandura's research. It's one thing I'd like to point out for you is that we really went into during the math anxiety session, we went into great detail on that physical and emotional state point, that you need to attend to the physical and emotional states that your students are experiencing, and so we're not going to touch on that today, but we will spend time talking about increasing the likelihood that students feel success building towards mastery, that we are cultivating successful vicarious experiences for students, and that we're providing positive verbal persuasion or feedback to them. So let's start with building mastery experiences, which Karen mentioned is the most potent and powerful piece of these 4 aspects of self-efficacy. It's the one that seems to be the most influential. And so for the strategy of increasing the likelihood of success to building mastery, There's a couple different approaches that are pretty typical. So the first of which is using scaffolding to promote success on challenges or tasks that are appropriately challenging for the students that your teachers are working with. The other approach is to help students set goals and track their progress so they can see the growth that they're making over time. So it's likely that your teachers are going to be familiar with some key concepts from developmental psychology, like the zone of proximal development. I just wanted to touch on that just so you can tie in with them. Vygotsky came up with this idea of the zone of proximal development way back in the 1930s, and other people realized that actually what he's talking about is something that could be described as scaffolding. So when it comes to the zone of proximal development, the idea is that students have a space of skills and knowledge that in which they can work unassisted, and that is that inner purple circle in this diagram here. And it's really sort of where they already have mastery. But if we want students to learn and grow, we want to push them into a sort of the next level of difficulty, which is that zone of proximal development in which a student can learn and can achieve, but they need some assistance, some scaffolding from their teacher, from the peers, from a carefully designed lesson, etc. And then finally, there is an outer zone of things that are just too challenging for a student to master at this given time in their development and their growth. But of course, over time, they will get there. It's just a snapshot of a current particular time point for these students. So the idea of scaffolding is that the task that a teacher is assigning should have students in that zone of proximal development so that there is scaffolding in place for them, and that the teachers gradually remove the scaffolds as the students learn the content or the task at hand. And so they're gradually working to mastery. And your teachers are probably going to be very familiar with this sort of terminology, but it's just a way to sort of frame this, or maybe a new way to frame this. These things that are not just good teaching practices, they also build self-efficacy for the students. So scaffolding, of course, is a building term. So one way that I think of scaffolding, and it's a way of building support, and building that support into lessons that help students eventually get to where they can independently do tasks that would initially be too challenging for them without some support. There's two different flavors of scaffolding that are often deployed. Those are bridges and ladders. And in either case, the idea is that a teacher thoughtfully in their lesson planning tries to develop incremental steps over which a student progresses as they go from easier to more challenging tasks, and they gradually increase what they're able to accomplish. A teacher also deploys scaffolding when they're delivering instruction. So scaffolding appears not just in planning, but also in the delivery phase. So let's talk about that bridge idea of scaffolding. So this is thought of as a horizontal method. It seems to me to be a strategy that would be most useful in the moment when a teacher is actually delivering instruction and needs to adjust on the fly and deploy some scaffolding pretty much immediately. And that is because to build a bridge, a teacher is evaluating whether or not what they're asking students to do is actually allowing the students to succeed. So for instance, they would model an exercise for the students with the intention that the students could go and work independently or work in small groups and have some success, even with the scaffold of a structured worksheet to work on. However, if the teacher is looking at the classroom and sees that students are not succeeding, well, then it's time to build a bridge. They need to create additional practice tasks, or perhaps start a classroom discussion so that the students can have a little more support and get a little more gradually faded direction from the teacher. So in this form of scaffolding, you're not necessarily increasing difficulty yet, but you're allowing more practice and maybe giving some additional entry points to the skills and knowledge that the students need so that they can succeed where they are. So the next form of scaffolding is building a ladder, and this is the more vertical method. And this, to me, makes sense to think of as starting with the teacher's planning phase, where a teacher works backward from what it is they want a student to know and be able to do by the end of a lesson. So what are those end-of-lesson expectations? And working from that endpoint, building progressive steps to build incrementally that would allow students to get up to that most challenging endpoint. And that most challenging endpoint can be thought of as the top rung of the ladder. So the teacher's lesson planning, they can evaluate whether or not the examples and exercises that they've built in are sufficient to help get students all the way to the top of the ladder. And if not, if there are some gaps, then it's time to add some rungs so that students have a little smaller increment between steps up that ladder. And so for this scaffolding, the difficulty is definitely getting more challenging for the students as they progress through the lesson. So scaffolding is kind of a broad term. There's lots of different forms of scaffolding that can be used. And so it's really important for teachers to know different ways of scaffolding and to consider how they can tailor the scaffolds they're going to offer to suit a range of learners that are in their classroom. And some examples of scaffolds that are pretty universal and can be used in math and other content areas are teaching academic vocabulary, which is vocabulary that appears across content areas in the classroom, but that's very important and meaningful vocabulary for students to understand to be successful. So an example of an upper elementary vocabulary word is analyze, academic vocabulary word specifically is analyze. The students could hear that word in science, they could hear it in math, they could hear it in English language arts, they could hear it in social studies, and so it's a term that they need to understand well enough they can use flexibly across the curriculum. And you don't want students to have to be thinking about and muddling over those words at any point. You want them to be comfortable with them. So teaching academic vocabulary actually is supportive of their math learning in the long run. Another scaffold is to allow students to use multiple modalities to learn, which means that they're using different means of working on a skill or grappling with content. So they could be writing about it, they could be listening to a lecture or video, they could be speaking about it. For math, they could be using manipulatives to make it visible and concrete, some sort of operation. They could be drawing a diagram of something for geometry. And the idea here is that students use different parts of their brains when they're engaging in these different modalities, and so they get more depth of thinking about the content when they're doing more things related to that content. This is not the same as having a different quote-unquote learning style for which there's very little research base. This is more about depth of thinking and depth of cognition, which is a really important distinction. Another great strategy for scaffolding is making sure you have different ways of making concrete the sometimes abstract concepts in math that students might struggle with, and using visual examples. And this can include not just manipulatives that are right there in front of the kids and they can touch, but also videos and animations that you could find online that show processes in action. A lot of people use the Khan Academy for this sort of thing, although those videos and animations are often kind of dry. But something that is great about using things like videos and animations to show examples is that you can pause them, and the kids can pause them, you can rewind, and so it gives them a chance to really, there's not getting a concept the first time, they can take a little bit of control, have some agency, and rewind and get some more exposure to the idea. Finally, another scaffold that teachers can do is to model their actual thought process, and this is something that students can be taught to do, which we'll talk about a little more in a moment, and that is thinking out loud so that the black box of what's going on in the teacher's mind is made explicit to the student. And a teacher can, as they're, let's say, solving an equation on the board, can be saying, I'm noticing here that this symbol is an addition sign, and that means I need to take these two quantities here, these two digits, and add them together. And so that gives the students an insight into what the teacher's strategies are, what details are pertinent to the teacher, how to interpret information that they're seeing. So it really just allows the students just a different entry point into actually what's going on in the teacher's brain, which can be very powerful for students who are struggling. And these scaffolds are good for any sort of students, but they're especially helpful for English learners if you have those in your school in great numbers. So another interesting way of using scaffolding is to use what are called low floor, high ceiling tasks. And we found some great examples of these at ucubed.org, which is a website by Stanford and Joe Bowler. So knowing how much work Joe Bowler has done in Washington State, you might already be familiar with this. But if you're not, I highly recommend you go to ucubed.org and you can look at their task library, and that is completely filterable. You can select specifically low floor, high ceiling tasks and then grade levels for those things to be filtered. And the idea of low floor is that it's something that has an easy access. Even beginners can have some success trying this task. But high ceiling is that it's challenging enough that even more advanced students will be challenged. So that's kind of an interesting sweet spot for a task where students from a variety of different levels can get an entry point and allows them some success. So the game I put up here is called Circles and Stars, and that is just one example of, I think this was a third grade level, low floor, high ceiling, a task that you could see that a student who is maybe just barely learning to think about multiplication could start working on through that concept in the more basic visual way, but then a student that has been learning more multiplication can be actually doing the multiplication in their heads and just getting more practice, more advanced practice. So something that you might want to discuss with teachers while you're addressing this idea of scaffolding is this asking them to think about if there's a tension between supporting students' mastery experiences and also making sure there's enough challenge for students. Some way I've heard teachers talk about this is the difference between, boredom versus productive struggle versus frustration, and really trying to have students in that productive struggle space. Sometimes teachers like students to feel like they're having mastery, and if you stick only in areas where students have mastery, you're in that innermost circle when we look at that diagram of the zone of proximal development, and so they may not be getting enough challenge. So this might be fertile territory for you to discuss with your teachers to see what they think on this, and maybe that could give you some insight on how to work with them to make sure that their students are getting enough challenge. All right, so the other strategy for building students' ability to reach mastery and building their success there is to help students set goals and track progress. And just like with scaffolds, there's this idea that you need to set your larger goal for the lesson or for the unit or whatever thing you're working on, and you need to break it into smaller chunks that are forward progression, developmental sequence going up to that most challenging task. And you want to set small attainable goals along the way. So the goals are meant to challenge the students but still be achievable, and it gives the students a chance to track their progress towards their goals, and so they themselves can see their successes and growth over time. And then it also gives the teacher a wonderful opportunity to celebrate student successes as they are progressing towards that ultimate long-term goal that you're working on. All right, so the next kind of strategy that we want to talk about briefly is vicarious experiences. And the idea here is to help students observe successes of others who are similar to them. As Karen mentioned earlier, it's really important that who the students are observing is similar. It's not convincing to students that in a way that would build their self-efficacy. If they're seeing adults successful at something, they would need to see their peers being successful at something. So one way of doing this is using class demonstrations, such as using a fishbowl activity and inviting students to be models during lessons. And an important caveat here that it's a good thing to remember and perhaps revisit that math anxiety deck is that you don't want to put students in a position where they're modeling in a way that would put them in a place of creating a lot of math anxiety. So you'd want to be really mindful, or the teachers would want to be really mindful of that with the kids. One way of sort of working on this is to make sure that the teacher has posted and discussed clear norms and expectations before beginning any sort of class demonstrations, especially if the students are going to be asking questions and giving feedback of the peers who are modeling, because you want the discussion to remain constructive, you want it to remain productive, and to be focused on learning. It's also really powerful to emphasize that during demonstrations that the goal is not just getting the right answer, quote unquote. The big idea is that they're learning math from observing and working with others. It's not about just successfully completing an algorithm and looking good. There's a really nice example of a teacher lesson doing a fishbowl at this Blogspot URL, classfruition.blogspot.com. If you're unfamiliar with the fishbowl, the general gist of it is that a small group of students, usually like 4 to 6, are seated in the middle of a circle, and all the rest of the students sit around them, maybe in chairs, taking notes. And the students in the middle are tasked to work as a group, thinking and talking out loud, to solve a particular math task. And as they do that, the observers around the edge of the circle can write questions, and at the end may be able to ask them. But the idea is that it's a way for the students to be showing that they're collaboratively working together, and also that they are trying new strategies that maybe the observers would not have tried themselves. And just one note about that fishbowl example of that Blogspot address. It is for a more challenging math lesson. It's for older kids. So the structure and the idea of the fishbowl is appropriate, but they would need to change the math task so that it's appropriate for your elementary age learners, for the teachers you work with. So another great way of building those vicarious experiences is to make sure that the class has a collaborative learning environment where students develop skills while observing their peers, and so they're seeing other people model strategies. And one strategy for doing this is called Claim Support Question. It's an instructional routine that was developed by the National Council of Teachers of Mathematics. And the general idea is that someone throws out a claim, potentially the teacher, and the students work in pairs or small groups to sort of test out the claim and see if they can find support for whether or not the claim is true or false. And as they're working through that, they might realize they have questions they're not sure about, and so they make note of them. So for instance, a teacher could start with a claim such as, all multiples of 9 are also multiples of 3. And then the students break into their groups and evaluate, coming up with support to whether or not they think that is true or false, find evidence for that, and make note of their questions they have. At the end of the time period that the teacher has them working, they can all share their questions of things that they didn't resolve together in their groups, and then they can have a discussion about that. A final strategy for building those vicarious experiences in classes is when you're having peer models, students demonstrating their math work, it's important to have some structured guiding questions that teachers can deploy that can help steer the conversation. Because, of course, students are thinking out loud, even thoughts that may not be productive or helpful can come out. So the idea would be to use guided questions to help guide, let the students not only make their thinking clear and simplify their thinking, but also give the teacher a way to make sure that students are attributing their successes to things they have control over, like the amount of practice they're doing. So examples would be if a student is working out solving a number sentence on the board, the teacher can say, tell us what you know about this, and point to particular steps. And then ask, how could you break this section here into smaller steps? How did you get from this step to that step? And based on the student's response, the teacher knows whether or not they need to try to redirect towards attributions over which the student can control. All right, so the last piece of this self-efficacy puzzle that we're going to talk about today is providing positive verbal persuasion. And that really boils down to giving students substantive process-related feedback that is specific and connects to their approach that they've taken to the end result that they're trying to achieve with the math problem they're working on. So this is very much aligned with what we've heard in other sessions on growth mindset. So in process-related feedback, the idea is to make sure that you're using process praise that notes the strategies and efforts the students are making and to be specific about that, rather than commenting on attributes of the student themselves. So for instance, you could say something like, that was great work, Salome. You remember to start by finding the greatest common factor for that equation, and then you were able to factor it out. So this sort of feedback is not only praising their work, their great work, Salome, but also very specifically calling out what it was they did that was effective, which helps not only build their self-efficacy, but their growth mindset. Another key factor, or trait, I should say, of process-related feedback is that for it to be effective, it needs to be honest and realistic. When students hear undeserved or insincere praise, they're not convinced by it. And so it's also important that teachers don't pretend that setbacks haven't happened and that students aren't struggling. Like, building up a student's self-efficacy is not pretending that they are not encountering difficulties and that they things they need to grapple with. So instead, it's important to acknowledge the struggle that a student is having, and then highlight specific strengths that could help the students cope with that struggle. So for instance, you could say, I can tell you're frustrated, Lila. You're having a hard time solving this equation. I remember how last week you did a great job of following the right order of operations. I wonder if you can use that knowledge now. So this is effective strategy, or excuse me, effective feedback, not only because it's honest, but also because it highlights for the student what they've had success with in the past, and highlights something that is specifically something they can apply in the present to solve the thing they're struggling with. So it gives the student a little bit of scaffolding in the mix. Another great trait of process-related feedback is challenging any negative self-talk that comes out when a student is discussing their struggles with a particular math concept or problem. So, for instance, if a student says that something is too hard, the teacher responds saying, "Darren, I heard you say this is too hard. It's true that this is challenging, and you might not be able to do it yet, but I know you can if you keep at it. Let me show you a different approach that might help." So we have a positive social persuasion scenario. This is an activity you can do with teachers when you're working with them in a group or even as individual. And the idea here is that we have a scenario in which a teacher has noticed a student, Tyrone, who's struggling with a particular math problem. And so the teacher, the scenario maps out what the teacher is telling the student. So you're just hearing the teacher's perspective on it. And if you're working with teachers in a group, you can have them identify examples of process praise, examples of the student noting something that is realistic or honest. And you can also see if the teacher has made the attempt to challenge any negative self-talk. And not all these things are present necessarily in this particular scenario. And again, if you'd like to edit it to make it fit for your work, you're welcome to. But it's just a little bit of practice for teachers to identify those traits of persuasive feedback. That would be great for them to be able to deploy in their own classroom. In sum, another way you can wrap up this section with your teachers is to allow them some time to reflect on which of those three practices or strategies we just went through they are most interested in. So are it mastery experiences, vicarious experiences, perhaps social persuasion? And then allow teachers to organize into groups that have that shared common interest and have a chance to talk to each other about how they would build these practices into their everyday math instruction. So they have a chance to not only talk about what they like and don't like about it, but come up with ways to apply in their classrooms and maybe learn from some of their colleagues that are also in their small group that might have different approaches to incorporating these into their work. All right, and now I'm going to hand this back to Karen, who will wrap it all up for us.
Thanks, Lauren. Since we are at the end of our time together, I wanted to spend some time today before we say goodbye thinking about what all we've talked about across these 4 training sessions and how they tie together. I think one danger in having presented these as separate sessions and have them separated across time is it gives the impression that these are, very separate and isolated aspects of attitudes. And of course, they are distinct from one another, but they're very much interrelated as well. And the 4 that we've dove into, sense of belonging, growth mindset, self-efficacy, math anxiety, they have in common that they are part of this basket of math attitudes, and they are distinct from one another, but they very much have relations. If we think about, for instance, growth mindset, we talked about how the practices that can promote growth mindset, and we know that growth mindset can shift with practices that promote growth mindset. We're really shifting to a classroom that emphasizes learning and effort over performance. And it's easy to imagine that that might also impact math anxiety. That takes the sting out of failure because we know in that classroom that mistakes are actually welcome. Likewise, if we think about how math anxiety might be related to these other attitudes, we talked today about how students use their kind of physiological reactions to gauge their self-efficacy, and those 2 things are related. So if we are using strategies to promote and help students to cope with their math anxiety, we'd expect that to perhaps promote greater sense of self-efficacy. We also talked today about how self-efficacy can be built by classrooms that have more communal practices, where students have lots of opportunities to watch their peers and see successes on the parts of their peers. So it's easy to imagine in a classroom where we have to spend a lot of focused effort on building a sense of belonging. When students feel more connected and have those relationships built with their peers, then they're going to be exposed to their peers having more successes, which could, in turn, build their self-efficacy. I think it's easy also to imagine links between growth mindset and sense of belonging. When we feel capable of growth in an area, we also feel probably more like a member of that domain. And I've just talked here about ways I can imagine these things being interrelated, but I think that they are going to be woven together in a complex way. And I say all this to just make sure we're clear and walk away from this training series by feeling like when we promote any one of these things, we're likely also to be promoting the others, and it's time well spent. I wanted to talk about a little bit about these separate training sessions and talk about the commonalities across. You saw lots of slides repeated and some redundancies across the different training sessions. And this was not to be redundant and waste your time, but rather for completeness, because as we've talked about, a lot of these things do carry over across the different math attitudes. So some of the commonalities you'll probably remember is each session we talk about the Farrington model, about how academic mindsets are important because they promote behavior that also then promotes outcomes. And so we tried to ground the sessions in these 4 key academic mindsets to help give people a structure for thinking about why we care about mindsets. We find in our work around SEL that teachers often have a hard time making a case to the higher-ups about the importance of these non-academic, these non-cognitive factors. And drawing back to this basic kind of logic model about why these things matter and how they promote academic outcomes can be really powerful. Other commonalities you probably have seen across the different training sessions was we focused on domain specificity. So today when we talked about self-efficacy, we talked about how that's something that students renegotiate for each different domain, each different activity. In belonging, we talked about how it's multidimensional and domain specific. So in math, students are not only negotiating their sense of belonging with their peers, but also with the domain itself. Do I belong in math? Is this a place I fit in intellectually? In growth mindset, we talked about how students are going to have different mindsets for different topics. They might feel confident that they can grow their language ability, but feel less confident about growing their math ability, for example. We also talked about, in many of the sessions, recursive cycles. So today with self-efficacy, we talked about how self-efficacy can change how students respond in the face of challenges. And when they respond more positively, it can promote this experience of mastery, which further promotes self-efficacy in a kind of circular way. That harkens back to what we talked about, for instance, in math anxiety, where we talked about how when students are math anxious, they avoid math, which leads to poor preparation, which leads to poor performance, which just further leads to more math anxiety. We talked about a similar cycle when we talked about sense of belonging, and how when students are unsure about their belonging, it can get them in this kind of negative loop where they are more vigilant to cues about belonging. They interpret those cues in the worst possible light, which only further decreases their sense of belonging. I bring up this recursive nature of many of these attitudes because I think it points to how very important breaking this cycle can be. When we change our classroom practice and use interventions to promote these attitudes, it can be really powerful because it disrupts that cycle and helps students reframe their experience and their challenges in more adaptive ways that not only promote belonging, but also are likely to promote growth mindset, self-efficacy, and lessen anxiety. Another thing that's common across all of the sessions was our focus on the potential for these attitudes to be more likely to be problematic for students that are historically marginalized. We focused a lot on gender and how there's something unique about math that sets girls and women up to be less confident in their abilities and hold more negative attitudes. And so in each of the sessions we talked about why math is a unique domain because it comes with some preloaded baggage with stereotypes about who's expected to be good and the kinds of abilities that girls are expected to have. We hit on this in each of the training sessions because we want to make it clear that there's the likelihood that these interventions and classroom practices can be particularly effective in helping serve marginalized students and promote more positive attitudes. We want you to take away from this training series that these sessions are very much intended to be modular. We have repeated these commonalities across all the sessions, but we want you to feel like you have the license to take them and break them up in ways that suit your needs. So for instance, if you did more than one training session in a day with a group, you might want to reduce some of that commonality. You might also want to add or exclude activities as is appropriate to your setting, and we want you to feel comfortable doing that. What is next? Well, from us, you can expect to, I will be in contact with each of you individually to talk about clock hours paperwork, and if that's something you would like us to complete for you. We will also be in touch when we have a final revised set of these materials for you. I've mentioned this throughout, but we have been taking the feedback we've received from you and also things we've learned, lessons we've learned, and presenting on these materials, and we've been tweaking the materials in ways to improve them. And we want to share those back with you once we've completed those revisions. There is something that we need from you, and that is your feedback. We are required, when we provide clock hours, to solicit feedback from trainees. We're also required from our funder, the Institute for Education Sciences, to get the feedback of people that we work with in our trainings. So we would like to respectfully request that you complete a feedback survey that I will be emailing out tomorrow. I'll send this around with a link to the video from today if anyone had to interlate, or for colleagues that missed it. I'll send that link out, but I'll also give you a link to this survey. And we really, really, really hope that you will consider responding. Your feedback is very important to us, and we will use it in our work moving forward. And it's very important to our funder as well. So look for that email tomorrow and maybe a pesky reminder or two in the days to come. We really appreciate you taking the time to do that. Now, we have just a few minutes before we need to hop off, and I would like to spend some time, if you are willing, thinking about the training series and doing a little bit of reflection. And if you have access to your chat, Lauren and I would love to hear from you, your thoughts on either of these questions. The first, what stood out to you? What's increased your knowledge or changed your thinking? And that doesn't have to be from today's session. It could be across the training series. And importantly, we're also interested in your input about what would be additional support that you feel would be useful. Now, having been through all 4 of these trainings, is there anything you wish, oh gosh, I really wish they would have talked about X when they talked about sense of belonging? So if you have any thoughts on either of those questions and you feel comfortable sharing them in the chat, would you please do that now? We'll take a minute and give people time to think. And if you could chat to all participants, if that's an option in your chat box, that would be great. You are a quiet bunch today. I will take that as a good sign that you're thinking deeply about all that we have imparted to you over these last few months together. Not to worry, you'll have plenty of opportunity to share thoughts with us when we send you out the feedback survey. I think that is it for us today. We do hope you keep in touch. We'd love to hear if you use these materials with your teachers and have any feedback or questions. We are more than happy to take those. We'd love to thought partner with you if we can support your work in any way around using these materials. You have my email address, and I'm happy to share the other team members with you. But in the meantime, keep in touch, keep doing good work, and we will send out an email shortly with a link to the video and getting your feedback on the survey. Thanks, everyone.